Hello, this is Jen. Welcome to this TopoDOT training tutorial. This is the 4-part video on Introduction to TopoDOT for mobile data. I'll start by creating a new file using the TopoDOT icon on the desktop. Then I'll create a new file, search for where I want to store it, give it a name, and then browse for the seed file for this project. We've created the seed file for TopoDOT in SurveyFeed in a previous module. Click on Save and this should start MicroStation. I know right away that I'm in MicroStation 3D seed file because I have multiple views, and by default I also have the tasks menu operating on the left hand side. This is not standard of MicroStation Connect. Go to the Intro to Connect video to learn more about how to turn on the taskbar. Since we have the taskbar on, I'm going to hide the ribbon bar using this arrow on the top. It will still let me access it if I click on any of these tools or toolboxes at the top. But for now, I'm just gonna make it or minimize it just so that we can use the taskbar on the left hand side more efficiently. Before starting TopoDOT, I'm gonna go and identify the proper settings for my drawing. I'm gonna click on Settings, File, Design File, and make sure that my working units are set to the units I want to work in. Also, make sure that the advanced settings for the resolution units are also set properly. If this is all correct, or if I've made any changes, I'm going to click on Save Settings and go back to the workspace. MicroStation by default saves all the line work. It doesn't save the settings such as the window arrangement, the units, the tool options, etc. So every time you need to keep those changes, make sure you click on File, Save Settings. I'm now ready to start TopoDOT. From the top menu, this will bring up these two windows. The text window, which will minimize right away, is an information window about TopoDOT. So this will let us know everything from version number, license information, and other operations that TopoDOT runs. We will be opening this window constantly to learn more about what's going on in the background. The welcome screen is a window with all relevant information about latest news, updates, upcoming webinars, and so on. You can close this window after you're done with that information. Then I will check the TopoDOT settings here on the TopoDOT settings tab, pointcloud file settings. A couple of important factors in this main tab are the units. If you're using LAS or LAC files, it's important to know the units that the data was saved as. That information is not available in the file itself. It's something that you need to know. If you're using .dot files or E57, that information is part of the file metadata, and this is not relevant. If your data was saved in a different unit system than your drawing or what you want to work in, it's important that you've identified here the units the data was saved as. So in this case, for example, my data is in international feed, and even though my drawing is set to US SurveyFeed, this will appropriately read the data in a national feed, scale it to US SurveyFeed, and allow me to work with the data scaled. If I later want to save or override the files with the data in US SurveyFeed, I can re-export those files. For this practice, make sure that you use the international feed setting. Another important setting is the limit incoming points. It is important to know how many points you can load at once. By default, this is unchecked because for the TopoDOT 64-bit edition, you can use more of your RAM than in the previous version, the TopoDOT 32-bit. Before, this option was usually checked and limited to about 100 million points. That is for 2 to 3 gigs of RAM. In the TopoDOT 64-bit edition, which is for MicroStation Connect, and especially for the version 11, you need to identify the number of points that you can load at once. So in my case, I have about 8 gigs of RAM. That means I can use about 200 to 250 million points at a time to operate MicroStation at about 4 to 6 gigs of RAM and leave enough memory to operate my other tools and any other programs that I have in the background. We've tested in a 32 gig RAM computer the capability to load about 1 billion points. So the amount of points that you can load at once depends on your RAM memory. For the other settings here, there are videos that are explaining more about these functions. For example, for the thin incoming data, you'll see more information on the filters video. For the thin static data by distance, it'll be on the introduction to TopoDOT static, and then the data noise thickness will be on the quality assessment tools. As for the other tabs on this menu, let's look at the next option, which is loading. This is a new option in version 11. This will allow you to balance between faster loading times or better visualization. It's preset to be at the better visualization end, but it's up to you how you want to balance it out. It's especially useful if you can use the faster loading times when you're doing assessment or doing some kind of check versus the better visualization when you're doing actual feature extraction. In the general files, there is more information about color. We will go more in deep about these functions on the drone or airborne tutorial videos and on the static videos. Here for mobile data, it's relevant to talk about this classification by flight line. It is not for this particular example, but if your data was merged into one big file, you can potentially separate it using this classify by flight line. It will only classify by flight line if the point source ID information is available within the LAS file. You will use the classification display mode to visualize each individual flight line or pass. If you don't see individual flight lines or passes, that means there was no point source ID information. If you leave it unchecked, you can use the classification mode for the actual classification layers or classes. In the dot files format tab, you have this option load as one file by default. This is if you have tiles that have individual pass information available within each file. You can keep them all as one file so that it's easier to group, or if you're doing any assessment or quality control, you can leave it unchecked so that it loads each individual pass or flight line for each tile. So for now, we're going to leave it off and I'm going to click on apply and save. I want to now use this flowchart to illustrate the process to load data. I want to start off by saying that this process is in constant flux with the QA/QC process as well. The management and assessment process in TopoDOT go interlaced because you need to be able to load the data in order to qualify it, and then once it's qualified, then you need to adapt it so that it's easiest to load. With that in mind, let's talk about what we're going to do next. Basically, we have a group of LAS files that are raw data files and that do not have a center line or alignment. So then I will create a center line using an aerial image to generate the tiles along the path, to parse all the data inside those tiles for later optimization, mapping, and loading. The only part that we'll miss here is this optimization, because I will want to have the original data files to do the quality check. After we do the quality check, we'll go through the optimization. This image is available on your class material and on TopoDOT University. In order to create a center line from an aerial image, we first need to establish the location of our project by mapping our raw data files. So I'm going to go to the second toolbar, pointcloud project manager toolbox, and go to register scan folder to icons by header. We're going to use the quick version. Then I'm going to browse for where my files are and select the folder. This is going to prompt me into saving the project TVW file or map of these files. I can call this project or whatever makes sense to you. This will identify which files are in that folder in creating that TVW file. Then I will map those files using tool number 8 under the same menu. Select the project TVW file I just created and click open. Hit the zoom to all view, and then I will see the icons that represent each one of my raw data files. Next, we're going to use the TopoAerial menu, which is under the first toolbox, the imagery toolbox. Click here on the load aerials tool. This will alert me that I need to select the coordinate system before actually using this tool. This is so we can locate the correct aerial imagery depending on the projection of the data. So in order to identify the coordinate system, this will prompt us directly to the coordinate system menu, or you can search for it by typing coordinate system in the search bar. I'm going to click here on the library and then go to the library, projected coordinate systems, North America, United States, then Arizona, and then I'll locate here the AC83 CIF right there. Click OK, and this will ask me if I want to use these units, and so I click OK and then close this menu. With that said, I can now go to the TopoAerial menu, and it should bring automatically the image for this area. If the aerial image that comes up is not the right image, it could be due to one of two things. It could be that the coordinate system is not right, or that the units are not right, or both. So this is a good check to know that indeed the units and coordinate system are correct. By default, it uses the Google Satellite Map imagery, but you can choose from other sources to bring the best image you can possibly have. Another good source of imagery is the Bing Satellite Map. We will go more in depth on TopoAerial on a separate video. For now, we're going to bring the current aerial to MicroStation. Then, in order to create the center line from the image, we need to identify some feature in the section to ensure that the data aligns with the image. In this case, we're going to use this bridge. Because my aerial image is very pixelated, very low resolution due to the size of the project, I need to maybe bring a higher resolution image by zooming into TopoAerial and then bringing that aerial to MicroStation. That'll improve the resolution of this image. This is only for the initial test. When we are using TopoAerial for feature extraction, there is an easier way to load all the higher resolution images of the section. For now, I'm going to minimize TopoAerial, and then focusing on this bridge area, I'm going to load the data relevant to that area. So I'm going to create a fence, and I'm going to make it quite big because I don't know exactly where the bridge lies within the data. Once I make that fence, I'm going to use tool number 4 under the pointcloud project manager toolbox to load data within a fence. I'm going to specify to load all files within let's say 1,000 feet of this fence, so that if there are files that are outside the fence and they have relevant data to this area, they can also be used. As you can see, the aerial image and the data are not exactly aligned. So we're going to use the bridge to line up or shift the aerial image into the data. This is just so that we can create that center line. We're not necessarily using the aerial image to do any feature extraction unless absolutely necessary, because we don't know when the aerial image was collected in comparison to the data. It can be sometimes used to extract certain features, but mainly it's just to have a general idea of where our project is. So this shift is going to take place in MicroStation, but it doesn't change the location of the aerial images in the future. So just keep in mind how you shift the aerial if you have to do it again. I'm going to clip out area of the bridge by creating another small box around the bridge, and then cropping all the data around outside that fence. Now I can easily identify features on the data and on the bridge around this corner. For example, I can create this place a smart line between this paint stripe here and the paint stripe in the data. Then using that line, I can now shift using the shift aerials tool, and I can do a little bit at a time, or I can measure the horizontal distance, hold control or hit enter, sorry, to snap to the horizontal distance, and that'll be 164.77 to the right, and then vertically it needs to be hit enter to lock it. It'll be 138.76. And now this aerial image should fit the data. I'm gonna delete this line, and now we can test it by loading another section of the data and seeing how well it matches. And indeed. So now I can be confident about creating that center line from the aerial image. I'm going to continue by unloading the point cloud and then zooming to all, and then go to place smart line, and then I'm gonna go ahead and start tracing my centered line from the aerial image. This center line doesn't have to be perfectly centered, it just needs to follow the road. Another alternative to creating this centered line is using the trajectory line from the system. If it can be exported as a DXF, it can be referenced in to MicroStation and be used as a center line. With this, we finished the setup process before we start tiling. So continue with the next video for the tiling process.